สวัสดีเจ้า I'm Pim Kemasingki, editor of City Life, and I'm back today on my sofa with little Miss Tiggie and my friend Paul Page, who is an expert on, it's a really random topic, not for you, I suppose, bees. He's a world expert on bees. So yeah, today we're going to talk about bees, which is something that I only know because of you, frankly. About 6-7 years ago, we used to meet in the evening at a local pub, and occasionally he would wax bees and talk about bees, and I'd be like, what? You know, there's so many like interesting facts. And so I interviewed you, 2018, yeah, and I did a cover story about you and your research. So I think it's time for us to catch up, right? So Paul, tell us a little bit about yourself.
So I'm a honeybee biologist, as just mentioned. I have a PhD in pollination ecology, and I've been coming to Chiang Mai now for about 10 years.
Long time. He's always popping up. I'm always seeing him.
Yeah.
Can't get rid of you.
So what brought me here was a Swiss project on resistance to parasites in honeybees. And the point here was to understand how the Asian honeybee, from which this varroa parasite comes from, resists the parasite and can cope with it. Whereas the European bee, usually if you don't help it, it'll be weakened and eventually they will die because of this.
Well, let's talk about this. I mean, this is probably like the zoom out question that everyone asks, right? Is it true that the world bee population is dying? Are we in crisis? Is the world over? You know, you've seen this in the press for a few decades. So go on, Paul, tell us, are we at the end of the world with the bees dying?
I wouldn't say the end of the world, but it's definitely a problem in beekeeping worldwide. As you know, so the European bee, Apis mellifera, is the main honeybee that's the most widespread for honey making and pollination services worldwide. The oldest traces we have of honey was notably in Egypt and Northern Africa, where we found traces of honey in clay pots, meaning that there have been humans have been harvesting honey and taking care of bees for about 10,000 years.
It's extraordinary, and it doesn't go off, so it doesn't ferment, it doesn't mold, it just lasts forever. And that's why they used it for
mummies. So as we know, Egyptians wanted to conserve their mummies for eternity, and to do that they would embalm their mummies with honey. So it's a product that we've been using for a long time. And
there you go, next time you want to keep a dead body forever,
embalm it with honey.
Lovely. So go on. So 10,000 years ago, humans started cultivating bees.
Yeah, and gradually, so we've been domesticating Apis mellifera, what we call the Western or the European honeybee. Bees naturally migrate. So normally colonies would switch from one place to another, depending on resources or the flowers they can find, climate conditions too. But what we've done with Apis mellifera is that we've selected it to keep it in boxes. So, and what we do is that we move the boxes around. We bring the box to where we need fruits to be pollinated or where we want to produce honey. So we've actually changed the natural character of the bee in this way that it doesn't migrate naturally, and we keep it in a box that migrates, and we move it around as human beings.
So do they even know how to migrate anymore?
Apis mellifera does not migrate anymore. If you look at the other Asian honeybee species, they naturally migrate. They can, Apis dorsata, for instance, the giant Asian honeybee can fly up to 200 kilometers.
Your one?
The one I have on my arm, yeah. To find a new nesting site or to find a new place for resources.
Okay, well, let's go back to the big picture. So you had the Western bees that had been cultivated for hundreds of years. So what happened? What was this crisis that they were talking about? When did this sort of get in the news?
So the first time we started to panic about bees, and it was about maybe 20, 30 years ago when we realized that we have a parasite on the Western honeybee that comes from the Eastern honeybee, from the Asian honeybee. This parasite, basically due to beekeeping practices, we gradually brought the European bee from Europe to Asia where it came into contact with Apis cerana, the Asian honeybee.
You said it took about 100 years for it to move across here, or how long did you say?
So no, we gradually, I mean, over the past centuries, we brought European bees to Asia. And since maybe 100 years, yeah, this parasite jumped over to the Western bee and spread all over the world into colonies of the Western honeybee.
And Asian bees are impervious to this parasite.
Asian bees can cope with this parasite. So the original host of this varroa mite
Yeah.
is Apis cerana, and it somehow manages to cope with the parasite, to keep it at very low levels, low thresholds, so it doesn't have an impact on the colony.
Right.
And that's what actually brought me to Thailand 10 years ago, is that I was interested in understanding these mechanisms, these processes of resistance to the parasite.
And that was actually what made me interested. We were having that drink that I mentioned, and he suddenly went into this whole varroa mites and started talking about their shenanigans, and it is shocking. Can we discuss a little bit of that? I mean, I couldn't believe the antics and the filthy stuff going on with your varroa mites.
So basically, it's like a tick. It's the family of the Acaria, and as ticks do, so they live on hosts for most of their lives. So this varroa mite basically lives in the colonies on the bees, on the adult bees. And when it wants to reproduce, female varroa mites will jump into a cell, a honeybee cell containing a larva, just before the cell is capped.
So just before the bees closes the cell, this evil little mite jumps into it with a little baby larva.
Exactly. So it jumps on the larva, starts digging into the larva, pierces the skin, and drinks a bit of its juices. Its juices, exactly. And eventually, she's going to start laying eggs. So the first egg she'll lay will develop into a male varroa mite, and then the following eggs will develop into females, so the sisters of the male. Eventually, as there's no other choice, the male will have to reproduce and mate with his sisters. So
incestuous mites.
It's an incestuous system, yeah. But somehow it works.
And then what?
So the three daughters, usually there's 2 to 3 daughters, will emerge from the honeybee cell.
Fully sated, eaten all the larvae.
No, not all the larvae, but yeah, fully sated for sure. And they'll then have eggs to lay, and then basically reproduce this mechanism. So as soon as they've gotten out of the cell, they'll live for a few days on an adult worker bee, and then jump into another cell, meaning that every 2 to 3 weeks, your population of parasites is going to double or triple.
Yeah.
Which is the main problem for the Western honeybee.
So what happens?
How fast it goes.
Kills the larva. It can't kill the adult.
It doesn't kill it. That's the problem. Right. It basically weakens the larva by sucking its juices, but the worker will still emerge from the cell and come out of the cell as an adult. But it won't be very useful, because it'll be weakened by first the varroa mite, secondly from viruses transmitted by the mite.
Right.
And there's up to 12 known viruses that are really can harm the bees.
God, so the mites aren't bad enough. The mites have viruses.
Exactly, yeah.
Oh
yeah.
My God.
One of them is one of the most common one is called deformed wing virus. So basically, it's going to deform the wings of the worker bee, and a bee that has deformed wings isn't useful. So basically, she's a burden for the colony. And eventually, if beekeepers don't treat the colonies against this varroa mite, the colony will slowly decline, and at least in Europe, within a year, it'll probably die.
So how do they treat them?
So there's all kinds of ways of treating them. When it first appeared, this parasite, we used the chemical products, so synthetic acaricides, so really aiming to kill the varroa mites. One problem with this is that these compounds would end up in the wax, they would end up in the honey, and then eventually people would be eating these acaricides. So it became a health issue too.
Right.
Gradually over time, I mean, there's still countries that uses, unfortunately, these chemical substances, but gradually we've switched to alternatives, more natural acaricides, such as formic acid and oxalic acid, and these are just basically sprayed onto the colony at some point, and it will kill the parasite. It has a slight effect on the health of the colony, though. I mean, there's secondary effects to it. but it's not as bad as the synthetic compounds we're using until now.
Okay, so when the scare came out 20 something years ago, so where are we at now with that scare? What has been done? I mean, is it as
Good
scary?
question. I mean, as a researcher and as a biologist, it's a question I often get is, so what are we doing to save the bees? Are the bees really dying? And when are they going to disappear? So there's two parts to that question. First of all, which bee are we talking about? When we're saying save the bees, it should be many species of bees. But we're actually... So there's in the world, there's 20,000 species of bees.
So we're just talking about one.
We're only talking about one. In these 20,000, we have 9 honeybee species, proper apis honeybee species. And most of them live in Asia. The only one actually that we're using for beekeeping doesn't come from Asia. It comes from Africa and Europe.
So the other bees, what's their purpose? Are they just useless? They don't produce honey?
Not.
What's their point?
Every bee species is useful. No, I mean, yeah, but that's exactly the point, is that we should be saving all the bees, all the different bee species. Every bee species is important in ecosystems and even in agricultural systems.
So they still pollinate?
So most species, yeah, bee species pollinate, exactly. They'll collect nectar or pollen from a plant and bring it to another flower, eventually, yeah, pollinating this flower and enabling the fruit to be produced by this plant. And that's the main role of bees. Now, honeybees often live, they live in, it's a social entity, so they live in a colony. So we're talking about thousands of bees within one colony. So they have a much greater impact on the flowers surrounding the colony than solitary bees, for instance.
Okay.
Most bees are solitary, meaning
they don't have a hive?
They don't have a hive, no. They have maybe a small nest. They'll lay a few eggs in a tube or in a hole in the ground.
How do they find each other?
Like most animals do, you know, they have places where they meet and, you know, they mate.
Okay.
Yeah.
Seems a bit harder than with the hives.
But then honeybees, yeah, it's a different process. I mean, yeah, they really live as a society, and which means that, you know, at one given point, you're going to have 10, 20,000 bees that are actually pollinating flowers. So they really have a big impact on fruit and vegetable production, on pollination services.
So tell us a little bit about cultivation of bees. So you said something like the maximum is 80,000 per hive, and then they've got to split it. And then what's all that about? Splitting and moving around? And
naturally, a beehive, it's different in the tropics as in temperate regions.
Yeah.
I'll give an example of Switzerland. So early in the springtime, so the bees emerge from winter. You have what you call winter workers that create this bundle to keep the queen warm over winter. So they're just producing heat for many months.
Yeah.
Just producing heat to keep the queen from prevent her from freezing, basically. And that's about 5 to 10,000 bees. Usually 5,000 is the minimum.
So they just flap their wings?
And not even the wings, they're flapping the muscles of the wings, and that creates heat just mechanically. And it keeps the temperature of about 25 degrees, actually, when it's below zero outside. It's crazy. If you open a hive in Switzerland in the middle of winter, which you shouldn't do because you might damage the hive. But if you do, and you put your hand on it, you can actually feel the heat. It's really impressive.
And opposing end, you said that they also can cool the hives.
They can also cool the hive, yeah.
How does that work?
Cooling the hive is actually, it's just like an aircon. Bees actually invented the aircon. They bring water into the colony, and then by venting the water particles, just as we do with the AC, it's going to bring the temperature down within the colony. So they create an air system within the colony and at the entrance to make the air circulate and the water evaporate gradually, and which will cool down the colony.
Quite extraordinary. I mean, didn't you say that most beehives have a temperature that's pretty static?
So where the brood is produced, so in the center of the frames of the combs, it's always between 34 and 35 degrees Celsius. So they tend to keep, it is hot. So most of the time in Europe, they're heating the colonies. Sometimes in the tropics, they have to cool them down. But they try to keep the ideal temperature for brood to develop, basically. It's 34.5 degrees. So yeah, they can regulate the temperature of the colony as
And don't
they
they
want.
use that to also kill?
That's another process. So they can do something that we call balling, but not all
Sounds badass.
not all the bees can do it though. But especially
Just the ballers.
yeah, the Apistrana japonica, so the Asian bee that you find in Japan, is very well known for this defense mechanism. So basically, if you have a hornet or a predator that enters the colony and gets into the colony, tens or hundreds of workers will jump on it and start doing this. They're shaking their wings and producing heat up to a certain point where the predator can't survive anymore. So I think it's about 40 bees. Honeybees can survive up to 43 degrees Celsius, and the hornets will die at 42 degrees Celsius. So basically, they heat it just above 42, which will kill the hornet. Yeah. So yeah, in Europe, you're gonna have at the beginning, early in the season, so in the spring, you'll have 5 to 10,000 bees in a colony, and gradually, as they go and collect pollen, nectar, the colony will grow and start building more frames, more combs, filling it with foods, and the queen will start laying many more eggs. As you know, a queen can lay up to 2,000 eggs in one single day. So her job is basically to lay eggs all the time.
That's a lot of eggs.
That's a lot of eggs, yeah. But if she wants to cope, and make her hive grow, then that's what she has to do. That's all she does, basically. She's been tended for, she's fed. All she has to do is lay eggs.
Kept warm. Yeah,
Totally.
not bad, not bad.
So that's what happens in spring, and the colony will eventually grow up to 60, maybe 80,000 bees in the middle of summer when there's a lot of food around. And then gradually, as winter's coming, the queen will start producing winter workers that are not foragers, but they stay in the colony, and they'll gradually take over on the summer workers and tend to the queen during the winter, feeding her and keeping her warm, as I just said.
What do they feed her with in winter?
So, well, the main food of bees is honey.
Oh.
That's what they do. Actually, the honey in a hive is the storage, is their
Right.
storage of food. So in times when, let's say, it's raining a lot and they can't go and get nectar from the flowers,
Right.
they're going to eat their own honey. Same thing in winter. You should always, typically in temperate conditions, you should always leave a few kilos of honey in the colony
For them.
for the winter, overwintering, or else they won't have any food and they won't survive the winter.
It's good to know.
So basically, yeah, they can feed on nectar, which is the same as honey, only
Yeah.
more liquid, or directly on their stock of honey. Yeah.
So, okay, so then what happened? So the European bee had this crisis. They found ways to deal with it. But you said that one of the reasons you came to Asia was to study to see how Asian bees coped with
Yeah,
this
exactly.
parasite and
Yeah.
perhaps taking this knowledge back. So
Yeah.
how's that going?
So that was a 3-year project that ended a few years ago. We published quite a few interesting papers from that research. Basically, the point was to know why the parasite reproduces only on male bees in the Asian honeybee, whereas on the European bee it can reproduce both on worker
Okay.
cells and on male cells.
So why?
And it's a different dynamic. If the parasites can reproduce in any cell, then it can expand, and yeah, it'll grow exponentially compared to if it can only reproduce in a few cells.
Right.
What we discovered is that there's different mechanisms actually in the Asian honeybee. The reason why it doesn't reproduce on workers is that workers that are infested with the parasites will actually have a higher chance of dying within the cell, and they'll be cleaned out by other workers. Once the larva or the pupa has died in the cell, you have what you call cleaner bees. They'll uncap the cell, see there's a dead larva in it, take it out and throw it out of the colony with its parasite.
Shouldn't.
So it's bringing the parasite level low every time.
And the parasite doesn't jump onto the cleaner bee?
No, it can't at that
Why
point.
not? Oh, it's dead?
Well, maybe one of them can, but they didn't have because the larva died. The parasite didn't have time to reproduce, so there was no daughters. And maybe the female will be able to do it, but then she'll again be the reproductive phase will be aborted by this mechanism. So basically, Asian honeybees are more hygienic. They do more cleaning and grooming than European bees. That's one reason.
Sounds
And-
about right.
And then this coupled to the fact that the Asian workers will die more often when they're affected by the parasites
Right.
gives this resistance mechanism to Asian honeybees.
So what can
And
you do with that knowledge?
now we can, a lot that has been done over these past years is try to select Apis mellifera, so the European honeybee.
Mm-hmm.
Try to find lineages that are susceptible, more susceptible, that will have this mechanism like the Asian honeybee does.
What, crossbreeding?
So then we do selection on these bees. Beekeeping, in beekeeping, we do a lot of crosses. Yeah, exactly. We cross different varieties. If a bee, this variety makes more honey, we're going to cross it with one that collects more pollen or that has more resistance against parasites. What you have to know is that Apis mellifera, the European honeybee, is a domesticated, fully domesticated animal. It's not a wild bee anymore, and that's very important.
So it needs its boxes.
To get through its bee. It needs boxes, and it needs constant tending by beekeepers.
Huh.
Most of the time, if there's no beekeeper to take care of the European bee, it will not survive. It'll either die of diseases, of parasites, of lack of resources because it's not moving around.
So they have to actively split the...
So the splitting is something else. So the splitting can happen either naturally. So what we call splitting is maybe swarming is a better word. So basically what I was saying before is when a colony grows to a certain size, then the colony will start producing queens, new queens, and also male bees for it to be able to reproduce further and to spread their genes. What a beekeeper will do at that point is he's going to artificially make a swarm. So he's going to take either a queen from another colony or a queen from the same colony, take half of the workers, put half in a box with a new queen, and keep the other half in an old box with the old queen. But this is something that happens naturally with the other honeybee species. Basically, when the colony is big enough, the old queen will fly off with half of the colony or a bunch of the workers, whereas the new virgin queen will stay, mate, and take care of the colony, the initial colony. And the swarming process can happen 2 or 3 times within a season too. The colony really grows. You can have 2, 3, maybe 4 swarms.
Really? In a year?
Created. Yeah, within even a few months.
Really?
There's enough food around, yeah.
It's so efficient. Yeah. It's so, I mean,
very efficient.
Do you know how the mechanisms of it even work? Like, how do they, who decides? How do they communicate?
We don't know.
It's just extraordinary.
I mean, they have a neural system. They have a brain the size of pinheads.
But yet together.
But all together, it creates what you call emergence of new properties. Basically, when you put all these, it's like a brain. You know, if you take just one neuron, it's not going to work.
Yeah.
But if you take 30,000 or 30 million neurons, they can all interconnect and something's happening.
It's so funny because it's so efficient and it makes so much sense, you know, the swarming, everything. And yet there's some weird ass behavior. There's some really strange stuff that doesn't make any sense, like the sexual lives of bees. I mean,
sexual lives.
Tell us about, I mean, I find that absolutely extraordinary. So so will you.
The mating system is quite interesting indeed. So, basically, each colony will only have one single queen, but this queen will mate with a bunch of different males. I think the World Guinness record was about 45 different types of sperm that we found in one single queen. So
how does this work?
How does what work?
Like, how does it get there?
So basically, when the queen is born, she emerges, and within the first few days or up to a week, she'll start to fly out of the colony and look for what you call an drone aggregation zone.
So she knows she's a queen from birth.
She knows she's a queen. She knows she has ovaries, and she knows she has to collect sperm from other bees to be able to inseminate her eggs, right? So what she does is she's going to find this cloud. We don't know how actually they configure or define where this cloud is, but it's somewhere around colonies.
Have you seen it ever?
I've seen it in Switzerland, yes. And it's maybe 10, 20 meters above ground. And you just see a lot of males flying around. And then all the queens of that region are going to aggregate and jump into that cloud.
One queen?
No, all the queens, yeah. And then basically one of the males, or the fastest male, the fittest male, is going to grab onto the queen in full flight and start mating with her in full flight, inserting his genitals into the queen. And
her
as you
belly?
know, what?
Into where?
Into her vagina,
Her
obviously.
Oh, I didn't know. I didn't know how it works.
There
Sorry.
we are.
Sorry, that's really
Queen bees have
embarrassing.
vaginas.
God, I sound like a 5-year-old. Into the belly with a stalk.
into the belly. Yeah, so he inserts his genitals into hers. And then basically he explodes in full flight, creating what you call a vaginal plug. So basically blocking the entrance to other males during a few hours, and making sure that his sperm will be able to be collected by the queen and stocked. She has spermathecs also, the queen. So she has ovaries where she produces eggs, but then in her body, in her abdomen, she has a bunch of places where she can store sperm for the rest of her life. It's called a spermathek.
For the rest of her life.
The rest of her life.
Okay, one goes in, plugs, and
Plugs.
then he explodes.
The queen goes back to the nest. He explodes.
He dies.
He dies in full flight. He had one good go, and that's it.
45. Do they just go in a line?
No, so then she goes back to the hive. Eventually, the vaginal plug will fall off, dries out, falls off, and then the queen can go back again. So within one day, she can mate a couple of times.
Oh, so
and
45
this
is not in one go.
No, not in one go. It's not.
Worried for her.
It's not a gangbang.
Getting concerned.
No, it's one after. It's still monogamy, but
Wow.
poly monogamy.
So she keeps this for life. And how long is her life?
So the queen usually can live up to 3 to 4 years. At least in Europe, we have after 3 or 4 years. Usually, she's done laying eggs, so she's used up all her eggs.
Right, so she's useless.
And at that point, the colony will actually feel by pheromones or by chemicals. They'll sense that the queen is getting weaker and doesn't have any more eggs to produce. And at that point, it can happen that the colony actually kills the queen to replace it. We call it supersedure.
It's mean.
So yeah, it is mean, but it's society. So replace the queen by a new one, and that's what they would do naturally. When you're beekeeping, it's a different process. Usually, it's the beekeeper that will see that the queen isn't doing too well, take a new queen from a different colony that's young and full of eggs, and put it into that box to keep it going.
So back to the queen and all the boy bees at 10, 20 meters. And so the ones who don't get to plug, what do they do? They just go back home?
That's a very good question. They become monks. Obviously, on the hundreds of males that are out there, some will never be able to reproduce. Right. But that's nature.
No.
It's
Yeah, so she comes back.
In humans too.
In cells. So she comes back to her place. She pops her little bees out into her little larva holes. With all the mites going in and doing their rude stuff.
Exactly. Yeah. So she's going to lay an egg, and that's why she has spermathecs. Actually, that's why she can store sperm. Because if she lays an egg without fertilizing it, it'll become a male bee. So it's one set of chromosomes. If she lays an egg and fertilizes it, then it'll become a female. It'll become a worker bee. So that's how it's not the same as X and Y chromosomes that we have in humans.
So female
bees
work.
It depends on either it's inseminated or not.
So male bees don't work.
Male bees don't work. They do nothing. They just hang around. They get fed.
Waiting to plug.
They're waiting to plug. Exactly. They're jumping around. They can actually change colonies and be fed by other workers from different colonies.
Sounds about right.
And they only get it does. They sleep, eat, and have sex once.
So let's come back to the Asian bees, right? So at this point, we've established that yes, there are concerns about the mites, but they are being mitigated, and there is enough of a industry that they can keep refreshing it, right? At this point,
exactly, yeah.
Yeah, and in the meanwhile,
it works.
There's 8 other honeybees in Asia, right? So what are we doing with these 8 honeybees? Is there much of an industry going on?
That's a very good point. So Apis cerana, which is the Asian honeybee from which this parasite comes from, and it's one of the only other ones that's a cavity nesting bee, like Apis mellifera, the European one. This one has been partially domesticated in Thailand and Southeast Asia. And it's been nearly fully domesticated in China. Oh. So it's also used for beekeeping in boxes in China a lot. No, this is quite recent actually. But the bee hunting and bee hunting with this Apis cerana has been going for a long time. So instead of having it all the time in a box, what people do here, let's say in Thailand at least, is that they'll set out a log, an empty log or an empty box, maybe put a bit of wax on there too. And that will naturally attract the colony to come.
Right.
So if there's a colony that's swarming or actually migrating, looking for a new place for resources, then they'll naturally enter this box, start to build some natural frames, maybe 4, 5, 6 of them, stay for a few months as long as they have food. And when the food is depleted, then they'll just bugger off and go to another spot and find another place with resources. So you can't really call it beekeeping in that sense.
Right.
It's more welcoming bees in a box for a certain given time.
And then when do they harvest the?
So in Thailand, you call it the 5th month honey, don't you? No? Honey, how would you say?
เขาเรียกว่าอะไรนะน้ำผึ้งเดือน5เหรอคะอ๋อเหรอ
Yeah.
รู้
Well,
ได้ไง
ching ching. So this is
Okay.
this is usually when they harvest it in Thailand. It's in May. In May.
Interesting.
Because it's the end of the warm season. It's just before the rainy season, and that's when actually the bees have stored a lot of honey to survive, usually through the rainy season. So that's when you cut it. But as soon as you cut the honey and the combs, then the colony will naturally swarm off and find another spot to build.
Right. So you said that the bee cultivation has become an industry in Thailand, mainly via Taiwan. What's that about?
So in about 50 years ago, 60 years ago, I believe, the Taiwanese started to bring longan and lychee from plantations in northern Thailand, and a lot of these orchards in northern Thailand come from Taiwanese settlers, let's say.
I didn't know that.
And so they were also, because they needed to pollinate their longan or lychee flowers to produce as much fruit as possible. They needed honeybees to do that, and the Asian honeybee would do it. But if you bring the European honeybee, then you have a more efficient pollination service going on.
Of course.
So that's why if you look at most boxes, beekeeping bee boxes in northern Thailand, they're based on the Taiwanese box. So they're not like we have in Europe. It's a different shape, a different frame size, and it's typical to Taiwan. Most boxes that you find now in Thailand are based on this Taiwanese model.
Right. Okay.
And so, we can say that the beginning, at least, of the beekeeping industry was developed by Taiwanese in Thailand. And gradually, now there's a lot of Thai people that do beekeeping.
Yeah, it's quite a big industry now, isn't it?
Yeah, it is,
Yeah. So, I mean, what other, like, we just talked to one of your friends just came here, and he's working with women in bees, right? So building female beekeeping as supplementary income, correct?
Exactly,
to low-income people. And then there's in Nan, or is it Loy, they use bees to deter, to keep elephants. Tell us a little bit about some of the creative things going on.
There's the different kinds of projects where we use bees. So the bee elephant project was initiated, I believe, in South Africa first with African elephants. And it is known that elephants are scared of bees. They don't. As soon as they hear the sound of a bee, they'll scramble off. They really don't like the bees because probably they got stung a few times in the past and don't want to.
Fair enough.
So people realized that it was a good way to deter elephants, and they start building fences, what's called bee fences, where they would hang bee colonies, beehives around the village to prevent the elephants from coming in. And it worked really well in Africa. Since a few years now, people have been doing this also in Thailand with the Asian elephants, and it seems to work very well. So, it's working,
Right, so we have a bit of a microphone problem, so excuse us sort of passing this to each other as we speak. So tell me a little bit about honey, like what do you know about it? What's it good for? What are all the differences? Is there fake honey out there? What's the deal?
Yeah, there's actually a lot to say about honey. I mean, it's so basically the honey is produced from flower nectar. Bees collect the nectar, they'll bring it back into the colony, they'll store it into cells, and they'll slowly dry it from maybe 80% moisture down to normally 18%.
With their wings.
With their wings. So there's different processes. First of all, they'll ventilate within the cell. So just the air circulating will dry out the honey. And then there's a licking process where they actually lick inside the cell.
Oh, nasty.
They're gonna regurgitate the honey many times. So it's honey is bee puke.
Gosh, you're definitely not in the marketing section of the bee world, are you?
I'm a scientist.
So bee puke.
Yeah, bee puke. So they do that many times until the water content goes below 18%. We call them in tropical countries since it's very humid. So it's more difficult for bees to get below already 20% humidity. And normally in temperate conditions, you're only allowed to pull honey. Well, in Europe, what we call honey has to be legally below 18%.
Right.
Water.
So we don't even qualify.
You don't. Well, not on European standards.
Is that why we can't export our honey?
That's one of the reasons.
What's another reason?
There's a few. Well, there's what you'll find in the honey. So you sometimes have traces of pesticides. It can happen. There's a study that was done by a Swiss team actually in 2016-17, and they actually tested 200 types of honeys from around the world that were brought to Switzerland. And they found that more than 70% of these honeys contained pesticides at different levels, some that could have been harmful for humans and some that were not. But that means that in a lot of honey, you find pesticides in trace amounts of this. So based on European standards, you're only allowed to have certain very small levels of traces of these potentially harmful compounds. Then there's the problem of the fake honey. It's a big issue. It's been a huge issue these past years. Fake honey, there's different ways of making fake honey. So the easiest, maybe the easiest is actually not to make honey, but to make sugar water, evaporate the water, and we call it honey. And that's basically it's not honey. It's kind of a syrup.
What? So someone just sits at home and makes it.
You can. They won't make it at home. It's on the industrial scale. It is known that some countries, let's name one, China, makes quite a bit of adulterated or fake honey. Another thing they do is that normally you always find traces of pollen in the honey too. And some people will filter out the pollen and to make their honey untraceable, basically, and then cut this honey with other honeys that are better quality. So basically, they're selling a lower quality product by cutting the honey.
So tell me, the other way of faking honey?
Another way of faking honey is just feeding the bees with sugar water. Basically, instead of letting them forage on flowers and collecting nectar, you just give them sugar water in the colony. They'll still make honey out of it, but it's not considered to be honey.
And is that happening?
This is a process that's not allowed typically in Switzerland or in Europe. They're not allowed. You can feed the bees at certain times just before winter, maybe with sugar water, but it's something that they'll eat.
Yeah.
It's not something that'll end up in the honey that you're going to sell. So, I can't say if it happens a lot, but I'm pretty sure that some people
do watch out.
Yeah.
So you mentioned earlier that there are 9 honeybees, right,
Species.
in the world, and how many non-honeybees?
So I said there's 20,000 bee species, well, insects belonging to the big bee family, let's say. Most of these species are what you call solitary bees, meaning that there's only one male and one female, which mate to maybe 10, 20 eggs and progeny, and that's about it. So it's what honeybees belong to what you call eusocial insects, meaning they're real society. They function as a society. In these colonies, so you're always going to have one queen laying eggs her whole lifetime, and which means that all her eggs, all the progeny will be sisters, and that's what gives the, let's say, genetic cohesion to the beehive.
But surely, as a scientist, I mean, you'd think that incest doesn't bode well for any species.
There's no incest with the bees, so that's only with
Oh, with the mites.
it's only with the mites.
Ah,
In the bees, no. In the bees, actually, the queen tries to reproduce with a bunch of males. So on average, it's about 12 different males, and that said the Guinness World Record is about 45.
45.
Different males. On average, if she has genes from 12 different males, she can actually produce a colony that's quite genetically diverse.
Okay.
All the sisters are going to have the genes of the mother, but some of them will have only half of the genes
Right.
in common with their sisters. It's, the other half will come from a different father.
Yeah. Okay.
That's what creates this cohesion in the society.
And what about sting bees and stingless bees? What's all that about?
Okay, so honeybees have a sting. They're stinger bees. And then in tropical countries, you have stingless bees. So it's a whole. It's like if you have.
Not the ones I've met.
No.
I've been stung.
So stingless bees are called Melipona bees. And it's about 500 species of Melipona bees.
Wow.
These are only found in tropical countries. So you will find them in South and Central America, in Africa, tropical Africa, and also Southeast Asia. To the 500 species known, there's 40 of them exist in Thailand. So we actually have a great diversity of stingless bees in Thailand.
And what does that mean?
So these bees are a bit different. They don't sting, first of all. To defend the colony, they produce a lot of propolis, so very sticky kind of, like some sap. They collect sap and resins from plants, and they create this very sticky substance. They cover the whole colony with this substance, and it keeps parasites and predators out, or bacteria. It's antifungal. Has really a lot of medical properties. So it's antifungal, antiviral, apparently too, antibacterial, and instead of making combs, these stingless bees with little pots, and they fill the pots with
I've seen them. Yes, yes.
And gradually, because the pot is made of resin, plant resins, the compounds of the resins are going to diffuse into the honey, and the honey will not only be sweet, but it'll be a little bit sour too. So it has a different taste to the honey that we have.
I tasted that at CMU. They let me taste that. It was so weirdly sour.
It is strange. But very different, but very particular.
Yeah.
And these now stainless beekeeping has been developed quite a bit in Thailand.
Yeah.
The friendly nets, there's a lot of that in Cambodia. So you can keep not all species, but about 6 to 10 of these stainless species can be kept in boxes. So transferred from a log into a box. And then, as the same as with honeybees, you can also split the colony when it gets big enough. You can harvest their honey, only they make little amounts of honey. You can maybe get half a kilo per colony or a kilo maximum.
Honey.
Yeah, really. But it's luxurious honey. Really, I'm looking to open a market for this honey too. Yeah, eventually I think there's potential.
I mean, what do you do? Like, what have you been doing all these years? 14 years, coming back and forwards.
So 10 years now.
What are you doing?
So now, I came here about 9 years ago, working really on honeybees and academic research of honeybees.
Yeah.
Gradually, after a few years, I did another postdoc, the Faculty of Agriculture, working more on pollination services and plant-insect interactions. And mocho, yeah. And since then, I've kind of dropped the pure academic research, and I'm teaching now in university in Korat, agribusiness, and on the side I have my own honeybee and stingless bee projects as an independent consultant and researcher. So I have a couple of projects both on Western honeybees, trying to find a variety that's well adapted to tropical conditions, that's resistant to varroa mites, for instance, that produces a lot of honey, that are gentle, easy to work with, and
companies come to you
and try. So I work indirectly, yes, with the company in France that works on what we call the buckfast bee. A buckfast is a variety that comes from Europe, and that they have adapted to tropical conditions too. And the idea would be to have this bee in beekeeping in Thailand. And then I have another project with the University of Neuchâtel in Switzerland and the Botanical Gardens of Neuchâtel, and they published that study on the pesticides in 2016. And here we're more investigating the different types of honey. So we're collecting more than 100 samples from 4 apis, so honeybee honey, and 6 different stingless bee honeys. And we're comparing what we call the metabolome. So it means all the organic compounds found in this honey to see if some compounds are specific to certain bees or to certain flowers, if there's some medical properties maybe in these honeys, and trying to figure out, what are the different, all honeys the same, or do they contain...
Are they great?
Well, I just brought the samples back. We haven't analyzed it yet, but I'll tell you next year.
Like, what are they doing at CMU? They've got quite a big bee department.
There's a there is a big. That's a very good question. They're doing some research, more on the parasites and pathogens of the bees, I must say. I haven't had much news from them lately, so I wouldn't know. From the Faculty of Science, but the Faculty of Agriculture, there's another professor who's working there more.
The one I interviewed, the one we met that day.
Oh, that's Michael Burgett.
Michael
yeah.
Burgett.
No,
we were sitting having another drink one day, and he was telling me about this world expert on bees, this man who he made the warning about the bee population declining in the 80s or 90s, and we were literally talking about him, and he just walked past.
We stopped him.
Hello.
Yeah.
Such a small town.
I mean,
we have basically one of the world experts in bees. Right here.
That's Michael Burgett. He's actually a retired professor from the University of Oregon, Oregon State. But he's been coming to Thailand for over 40 years now.
He was
every year.
Playboy as offering the most popular university course in America. I think it was The Sex Life of Bees.
Really? Yeah, he has a lot of knowledge, and good stories to tell. Yeah.
So, what's next? So you're still in Khon Kaen?
So now I'm in Korat.
Why do I keep seeing you?
I love Chiang Mai. No, I'm working in Korat right now, but gradually I'd like to come back to Chiang Mai and develop some more projects on bees. Possibly something more applied, something more social, maybe with beekeepers, or training for beekeepers, trying to involve local people into beekeeping practices, and especially with stingless bees.
So is there anything else you want to add about the bees? I think we've pretty much discussed the birds and the bees.
Mainly the bees. I think it's important to try to learn more about bees and pollinators. I mean, to conclude, you said, are we saving the bees? What can we do to save the bees? And often people think we have to save one honeybee species, which is Apis mellifera, the western bee. But this we can't save this bee somehow. It's a domesticated bee. Right. The only way to save it is to keep on doing beekeeping. I think it's more important to emphasize the fact that we need to save the other bee species, the wild bee species that are also affected by habitat fragmentation or pesticide use, or we don't know much about yet. So a lot of research still has to be done on bees, and definitely try to find more applications for beekeeping with stingless bees, for instance, that will actually help to conserve these species, because we're using them for beekeeping too. And there's different projects that can be done in that direction.
Is it a big bee world? Are there lots of bee researchers?
There are actually a lot.
Really?
There are a lot.
You're my first that I met. Yeah.
I went, I think 2015, I went to Apimondia. Apimondia is the biggest bee research and beekeeping conference in the world, as the name says. It was in South Korea at the time, in Daejeon. And it was 8,000 to 9,000 people. It's huge. Wow. And basically it brings together all the bee researchers and beekeeping communities, beekeeping industries, of course, to one place for maybe 7 days, and we interact and share our ideas and present our research. And it's huge conference. I liked it a lot. It was a good experience. But no, there's a lot of bee research being done. Research takes time. I mean, it's a long process. Yeah.
I interview a researcher, and I'll have the results for you in maybe 10 years.
10 years. Seems right.
Well, Paul, thank you so much. It's been lovely talking to you again. And I look forward to having you back on my sofa.
Anytime. Yeah.
All
Thanks for
right.
having me, Pim.
Thank you. สวัสดีค่ะ
สวัสดีครับ